Hi, my name is Fred with Android Developer Relations Team. We're going to talk about improving Android Studio performance on memory-constrained computers. Android Studio comes with many features developers expect from a modern IDE. For example, lint checks help identify errors as you're typing source code in the editor. These developer productivity features mean increased resource requirements on the host operating system. Practically, developers working on complex multi-module production projects usually have 8 GB of RAM or more. However, if you're working on a simple project on a memory-constrained computer with, say, 4 GB of RAM or less, we're going to go through several things you could do to make the development experience a bit smoother. There isn't a definite answer on the minimum specs needed to run Android Studio because there are so many factors. An obvious first step is close any unnecessary applications on the operating system. Sorry for those users that keep 20 web browser tabs opened. For those that have antivirus software running on the computer, note that build files generated by the IDE may trigger real-time virus scanning. This competes for system resources. If possible, go to your virus scanner configuration and exclude project build output directories. Android Studio has a default maximum Java heap size of 1.2 GB. If your computer has low RAM, you should correspondingly reduce the default heap size to something like 512 MB. You can set the desired values using the XMX key in the studio.vm option configuration file by following these instructions. Note that reducing this value means shrinking the amount of resources for features within Android Studio. For example, performance of the layout editor may be affected. Now, let's talk about Gradle, one of the core components in Android Studio. Update to the latest versions of Gradle and Android plugin for Gradle to ensure the latest performance optimizations are available to your project. For example, in 3.0, we've improved incremental packaging with AAPT2. The snippets here shows specific configurations for the Android Studio 3.0 beta version. Your specific installed version may need a different set of values. Next, I'm going to talk about several techniques that have to do with degrading support and leaving only the bare minimum running. Note that some of these techniques could provide performance gain at the expense of code quality, so you really should use with caution. Android Studio provides a power save mode. When turned on, it will disable a number of background operations that perform lint checks, code completions, and so on. There will be a point in time when you want to execute any disabled operations manually. Take lint checks, for example. You can manually run them through the command line, as shown here. Some of you may be using the Android emulator. On average, it consumes 2 GB of RAM. If possible, use an actual Android device. This will help reduce resource load on your computer. Alternatively, if you must use an emulator, consider reducing emulated RAM, which will also decrease virtual memory consumption on your computer. This configuration can be found under Advanced Settings in Virtual Device Configuration. Gradle Offline Mode is a feature for bandwidth-limited users to disable downloading of build dependencies. As a side effect, this could help improve performance on low RAM machines since this also reduces the amount of background processing. Android Studio offers an optimization to compile multiple modules in parallel. On low RAM machines, this feature will likely have a negative impact on performance. You can disable it in the compiler settings dialog. I hope this video gives you some ideas on how to fine-tune Android Studio and your low RAM environments to make the development experience smoother. To learn more, check out the Android developer site. Thanks for watching.